In today's lesson, we're going to build off of the distance and time graphs that we looked at in the previous lesson and look at more of how we can represent that movement in different ways. And those different ways are going to be those multiple representations that we've already seen in previous lessons. So looking at it in words, in an equation, in a table of values, and in a graph. So starting off, we're given in words the scenario that I start 6 meters in front of a motion sensor and walk away from it at a rate of 2 meters per second. So I'd say the easiest one to think of right now is let's graph it, because that's what we just looked at in the last lesson. So if I'm starting 6 meters away, you can remember for our graph, we have time on the bottom, we have distance on the side or on the vertical axis. So when the time is 0, or at the start, I am 6 meters away. So I should have a point here. Now if I walk away from it at a rate of 2 meters per second, that means after 1 second, I've gone 2 meters further, so I'm 8 meters away in total. 2 seconds, it's 10 meters. 3 seconds, it's 12, 14, 16, 18, and so on. And there's my line. And we know from our previous lesson that that's what our line would look like if we're walking away from something at a constant pace. So here we're walking away from something at a constant pace of 2 meters per second. For a table of values, again, we can just take those key points that we've already put down in our graph into a table. Again, x is first and then y. X, remember, is the horizontal, y is the vertical. So that means when x is 0, y is 6. Then we go up 1 second each time. So 1 would be 8, then 10, then 12, 14, and 16. From here, now we should be able to determine our equation. I'm going to use y equals. We know from our table that our starting value, or when x is 0, that is our b value, or our y-intercept. Right? So again, we have different ways we can figure it out. So that b value in our equation, let me just write down the general equation, y equals mx plus b. Right, with the b value being our y-intercept or starting value, and our m value being the slope. Oops. So far we know from what we've already done, we know that our b value, we have something x plus, we know our b value is 6. That's our starting value, that's our y-intercept, that's when x is 0. Now I need to figure out my slope, or the m value. And you can figure that out in different ways. Right? You could look at, okay, well, what do I increase by every time I move over 1 in my graph? I can look at my table of values and say, okay, what's the change in y? What am I increasing by or decreasing? And here we're increasing by 2 every time. And you could also go back to the word scenario, and it tells us a rate. And again, another word for the m value or the slope was rate of change. So whenever we're given a rate, chances are that's our multiplier. So we have a multiplier of 2. And again, in the words, we didn't really mention it, but the starting value, I start 6 meters. That should tell us the b value as well. And we've seen contexts like that before. So we're going to go through and we're just going to look at, again, a couple different representations of this, so we can get an idea of when we're given different scenarios, can we come up with the other representations. The next one, I start 2 meters in front of a motion, 20 meters in front of a motion sensor and walk towards it at a rate of 4 meters per second. So the two key numbers that we want to focus on are the starting 20 meters and the rate of 4 meters per second. Those are the two key things that we want to focus on. Those are our two numbers. Let's try to jump right to the equation. Again, we know it'll be y equals mx plus b, right? Again, m being the slope and b being the starting value or the y-intercept. From our context or the words, we can already see what we start at. Wrong color. We start at 20 meters. So we know our starting value is already going to be 20. So I know it'll be y equals something x plus 20. Now, where in this word scenario would my slope be? Well, it talks about a rate of 4 meters per second. So I know that my m, or my slope, or my multiplier should be 4. However, there's one key difference here. And the key difference here is this part where it says walk towards it. And when we walk towards something, the distance is decreasing. So we've seen on a graph before, when we walk towards something, it's decreasing. So that means our m value is actually going to be negative. So that's what walking towards it means. It means it's a negative multiplier, a negative rate of change, because the distance is decreasing. If you couldn't jump from the equation or from the words right to the equation, I would suggest then graph it, right? Graph our scenario. We know we start at 20 meters away, and every second we move 4 meters closer because we're walking towards it. So that means after 1 second, we're at 16. After 2 seconds, we're at 12, then 8, then 4, and then 0. And again, if I draw a straight line, that looks like what moving towards a motion sensor looks like based on our previous example or previous lesson on movement. We can again see that b value, that y-intercept where we start, and now we can take those points and plug them into our table of values. So when x is 0, y is 20, x is 1, it's 16, 2, it's 12, 3, it's 8, 4, 5, and, not 16, going the wrong way, 0. Again, you can figure out from here, your b value is when you start. When x is 0, what is the y value? And you can find your multiplier by seeing what do you change by in the y values every single time. So you can see we're decreasing by 4. So again, that's how you can figure out, again, the slope or the multiplier. And that's, again, we can see now in the graph that it should be a negative slope, which again we picked up from when it mentioned walking towards. Looking at another context or another scenario, when you join Netflix, you pay $8 per month. That's the scenario. You're only paying $8 a month. So there's only one number here. So that means our equation is only going to have one part. We know it's still going to form the form y equals mx plus b. But we're not going to have one of those values because we only have one number here. Now, you might be able to figure out which number we have or which variable we have, whether it's the slope or the y-intercept. And you can also think, well, what is this number that's given to me? Is it a starting value? Is it a single value? Or is it a rate? Right? Is it something per something? And again, we do see that it is $8 per month. So because it's per month, that's a rate. That means that in our equation, we'll have y equals 8x, so 8 times however many months. And we don't have a starting value. So in this case, when you join Netflix, you don't have to pay a fee up front. You're just paying per month. So in this case, our b value would be plus 0 because we don't have a starting value, or our starting value is 0. but we don't need to show that because, again, if you're adding 0, you're not really changing anything. Again, if you couldn't jump from the words to the equation, maybe try to fill out the table of values or the graph first. For the table of values, X is the number of months since joining Netflix. So we start at 0, 1, 2, 3, and 4. So if we don't join Netflix, do we pay anything? No, we don't pay anything, so our initial amount or total amount paid is 0. If we join for 1 month, we pay $8. 2 months, well, it's another 8, so we're at $16. 3 months, 24. 4 months, 32. With this table, right, we can plot these points. 0, 0, 1, 8, 2, 16, 3, 24, and 4, 32. So we can see we have a straight constant line because we're increasing by a constant rate. Similar to how in movement we're moving at a constant speed, here we're increasing at a constant rate of $8 per month. Again, we can see our y-intercept, or that b value, where it crosses the line. We can see that it is 0. We can also see that from our table of values. When x is 0, y is 0, so that's our b value. And we can see our slope, or multiplier, because we're increasing by 8 every single time. So again, that's where we can get our different pieces. Lastly, this time we're given the equation. So y equals 500 minus 20x. So this one's written a little bit differently. In this case, it'd be written as y equals b. And in this case, because our multiplier is negative, it's minus mx. So you can have your equation of a line written differently, and sometimes it's a little bit easier to understand what the scenario is when it's written like this. Usually when we're dealing with a negative multiplier, it helps to understand a little bit better here, because we're starting at a value and we're taking away from it. So from this, we could create a table of values looking at 0 number of weeks, 1 week, 2 weeks, 3 weeks, 4 weeks, using the equation. So we could take this and plug in a value for x and solve for y. So when we're given one part, we can say y equals 500 minus 20 times 0. And y would equal 500. So that's our initial value. For when we have 1 week, we could do the same thing, y equals 500 minus 20 times 1. And we get 480. And which makes sense because we're decreasing by $20 or by 20 every time. Now you don't need to show this work in each box. It might be helpful for the first two, and then you figure out what the pattern is or what you're decreasing by every time. So I'm going to decrease by another 20, get to 460, 440, and then 420. With this now, I can figure out, I can graph it. So at 0, I start at 500, and again, you might have been able to figure that out anyways from the b value. At 1, I'm at 480. At 2, I'm at 460, 440, 420. So we have it a little bit shorter. Again, we could have maybe done 2, 4, 6, 8, 10. And again, you could use the equation for that. So let's say, for example, at 10 weeks, y equals 500 minus 20 times 10, which we get 300. So at 10 weeks, we're at 300. So again, we have a steady decline. We're decreasing by a specific amount. Now, in terms of the words or the context of the situation, so let's that's actually taking this and putting it into words. Similar to how when we would take an equation or a rule and turn it into a visual pattern, we're going to take this and turn it into words. So we know we're dealing with account balance and number of weeks. So you could have something like, you start with, and again, we know our starting value is 500. We start with $500 in an account. And withdraw $20 per week. So you're taking out $20 per week, so you're losing $20, or your account is losing $20. So that would be an example of a scenario. Right? You could have something slightly different, but because we're already given the titles of the account balance and number of weeks, we do kind of have to keep it somewhat in the same kind of scenario. So the main thing here, we've done this type of thing before with the different representations, going between words, an equation, a table of values, and a graph, and understanding how we can find the B value, the B value, whether it's from a table or a graph, finding the multiplier, right? So the idea, it's the same thing that we've done before. The only difference is this time is, one, we've looked at movement, so we know or have a better sense of how the graph should look in terms of increasing or decreasing. And we've added in some scenarios where our multiplier has been negative. On most of the ones we've seen in the past, the multiplier has been always positive. But we do have scenarios where it could be negative, right? Whether we're withdrawing money or losing money every week like we see here, or if we're moving away or towards an object, so our distance is decreasing, we have that here, right? So that is the new thing right now, looking at or incorporating negative rates of change or negative slopes, negative multipliers, negative m values into our equations, and just seeing that we can come up with the different representations for them, the same as we've done in the past.